In this part of the lesson, we're going to explore what c does to the graph. So we're talking about when our quadratic is in standard form and c is the constant that's added at the end. Sometimes c is 0, and so you won't see anything there at all. But for these three examples that we're going to look at, c has a value. On this first one, c has a value of positive 2. On the second one, it's positive 4. And on the last one, it's positive 1. And so what I want to do is look at how that affects the graph. So first we're going to start by graphing this first equation. And I have it graphed for us here in Desmos. And what I want you to look at is what is the y-intercept for this graph. If we look at it right there, the y-intercept for this graph is 2. So let's write that down. The y-intercept for this one is 2. Now we're going to graph equation number 2 and look at what its y-intercept is. So when we graph this one, there's our vertex, 1, 3.5. And here's our y-intercept, 0, 4. So this one has a y-intercept of 4. And then on the last one, we're graphing negative x squared plus 3x plus 1. And this one you see opens down. We're still looking at the y-intercept, which is over here. That's going to be 0, 1. So this one has a y-intercept of 1. Do you notice any relationship between the value of c and the y-intercept? Hopefully, yes. So is there a way to find the y-intercept without graphing the function? Then the answer would be yes. And so you would just say, just look at c. C is the y-intercept, as long as it is in that standard form, ax squared plus bx plus c. If we were going to write each of those y-intercepts as ordered pairs, we know when you write an ordered pair, you write the x value first and then the y. And so when we looked at those for that first one, for the last one, it was 0, 3. For the one before that, it was 0, 4. And the one before that, it was 0, 2. So let's write all those down. We had 0, 2, 0, 4, and 0, 1. So what is the x value for all of your y-intercepts? Well, the x value for all of them is 0. Would that be true for all y-intercepts? Well, think about y-intercepts. They have to be on the y-axis. Whether they're positive or negative, they have to be on the y-axis. And the y-axis is where x equals 0, because you haven't moved to the right and you haven't moved to the left. So x has to be 0. So yes, because they're on that y-intercept. Okay, the next thing we're going to do is we're going to look at the x-intercepts. And let's see. The first equation we're going to do that for is y equals x squared plus x plus 2. And right now we're going to graph them using the calculator and just state what the x-intercepts are going to be. Later I'll show you another way to find x-intercepts, but for right now we're going to graph them just like this. So I've graphed this first equation, x squared plus x plus 2, and where does it hit the x-axis? Well, it doesn't hit the x-axis anywhere. So our answer to that first one, x squared plus x plus 2, what are its x-intercepts? Our answer would be there are none. So sometimes we have a parabola that doesn't hit the x-axis at all. And it could be because it's sitting up here like this, or it could be down here like this. But our first one right here is an example of a parabola that doesn't cross the x-axis. The next one we're going to look at is different from the one on your worksheet probably, and this is going to be y equals x squared minus x minus 2. Let's look at the graph of that one. Let's turn that first one off. When we graph this one, so there's our y-intercept, 0, negative 2, but what I'm interested now is where does it cross the x-axis? There's one right there at negative 1. and one right there at positive 2. So our x-intercepts for this equation are negative 1 and positive 2. And then the last one we're going to look at is y equals x squared plus x minus 6. We're going to graph that one right here. We have a couple of x-intercepts. We have one right here at negative 3 and another one right there at positive 2. So this is another one that has two x-intercepts. They are at negative 3 and positive 2. I'm going to teach you how to do this also using your TI calculator. There's another video posted that is just about how to find x-intercepts. There are several steps you have to take. Desmos is a great calculator for exploring, but you have to have your computer when you're doing that. So I want to show you also how to do it with your TI so you can have just your hand calculator with you either way. So that is on this page. We explored C. We saw that C was the y-intercept also, which is very handy to have when we're trying to graph something. That all of our y-intercepts always have an x value of 0. And we learned how to find the x-intercepts if we have a calculator. And that's it.